now we are going to discuss about our next topic, which is the Bucky balls. Bucky balls are basically an allotropic form of carbon, such that let us just understand the forms of carbons and how many allotropic forms of carbon are there. Basically, the allotropes of carbon are those allotropes of those compounds which are is allotropes of those forms of the same element, those forms of the same element which are uh, which exhibit same chemical properties but their physical properties are different, which exhibit the same chemical properties but their physical properties are different due to the difference in the arrangement of the atoms of that element, or as well as the difference in the bonding of the atoms of that element. So if we talk about the allotropic forms of carbon, there are two major allotropic forms of carbon, which allotropic forms of carbon are classified into crystalline form and amorphous form. I'm just writing the short form of it: amorphous and crystalline form. Crystalline form is further classified into, first let's discuss amorphous form. Number one is coke, which we have previously discussed. The 98 to 99% of coke is carbon, which is used in the which is used as a reducing agent as well as for electricity generation and other such is for electricity generation as well as a fuel, as well as for reducing purposes, reduce as a reducing agent. On the other side, if you talk about coal, coal is basically what it is, um, an amorphous form of carbon, which is also used as a it is also used as a fuel. So we have studied the entire process with how coal is formed, the process of carbonization in which the wood is converted into peat under bacterial and chemical reactions, and after that peat is further converted into lignite under a high temperature and pressure, and then lignite is further converted into bituminous coal, and bituminous coal is further converted into under high temperature and pressure into the purest form of coal, which is known as the anthracite. So this is the entire process we have previously understood. Now, when it comes to the crystalline form is basically having crystalline form is having three major types. Which number one is in which is known as diamond. In diamond, we have got a giant structure such that the carbon atoms are arranged in such a manner that one carbon is having four other carbon atoms. One carbon is having four other carbon atoms joined with it, causing to form a giant structure. Causing to form a giant structure. Of course, it's difficult for me to draw over here because it's going to be a giant structure. So over here, the giant structure is arranged in a vertical form such that all valence electrons of the carbon are occupied within the diamond. Due to which, as a result of the giant structure formed, what actually happens in the giant structure is that the number of carbon atoms which are arranged per unit volume are increased, due to which the number of chemical bonds which are found per unit are increased, due to which the carbon atoms are having high charge density, as a result of which they form a stronger compound when they are in a giant structure, due to which the carbon is considered to be the hardest substance. As a result of the giant structure it forms, even though the bonding within it is known as a covalent bond, which is a weak type of bond as compared to ionic bond. So in that sense, this is an important point. And the temperature at which carbon diamond is melted is also quite high, around to around 2500 to 3000 centigrade. So it's quite high as well. Secondly, we have graphite. Graphite is a form in which the carbon atoms are arranged vertically, sorry, in horizontal forms, such that one carbon atom is having three of its valence electrons occupied and one valence electron is not occupied in the horizontal direction, due to which graphite is able to conduct electricity in the vertical direction but not able to conduct electricity in the horizontal direction. This property is known as this property of the crystalline solids to conduct this property of crystalline solids to perform to have certain physical properties in a particular direction are known as anisotropy. This is known as anisotropy, which is possessed by graphite. All right. And after that, the third form which we are going to study today is fullerene. Fullerene is basically the form which was named after Richard Buckminster Fullerene. He was an American architect who basically built um, a geodesic, a dome type structure, a dome basically, which was known as geodesic dome. That geodesic dome was built by an American architect, Richard Buckminster Fuller, in Montreal. At that moment, what he actually did was, when he built the dome, that dome basically had the structure, geodesic dome had the structure which resembled with the structure of the Fullerene, which was known as Bucky Ball, and that Bucky Ball was named after the name of that American architect who built the geodesic dome in the Montreal, which was who was named as Richard Buckminster Fuller. So, on the basis on the behalf of his name, the name of Bucky Ball as well as the name of Fullerene is given. Fullerene are further divided into two types, which includes hollow spherical cage shape, which is a form in which the Bucky Ball is formed, right? And second, the highest form is tubular form, such that within fullerene we have the range of carbon atoms. If let's say, if we talk about the range of carbon atoms, the lowest carbon atom fullerene is C20, and the highest carbon atom, sorry, it's not C20, it's C40. The lowest carbon atom range is C40 and the highest carbon atom is C100, such that the lowest fullerene is C40 carbon atom containing and highest fullerene is C100 carbon containing. Now, in between them, the fullerene which is the most stable form of the fullerene is C60 form. And that C60 form is basically what we call as the Bucky ball. That buckyball is having a hollow spherical cage, as you may see in the diagram as well. This is a hollow spherical cage shape form. And when it comes to its discovery, it was discovered by three scientists named as the Richard Simele, Robert, Richard Simele, Robert Cars, and Carotone. Carot. Caroto, Robert Karls, and Richard Simele were the three scientists who discovered this new allotropic form of carbon, buckyball, on the basis of which they also got a Nobel Prize in the field as well. So, in that sense, um, this was a basic discovery, and this was named after the American architect who was not basically a scientist but who was an architect who built the geodesic dome, which had the structural resemblance with the Bucky Ball, due to which that scientist was honored, and his name and the name of Bucky Ball was named after him, so it was an honored name. After that, when it comes to structure is in such a manner that it is basically a nanoparticle. Buckyball is a nanoparticle. What does this mean? It means that it is having its diameter as around its diameter is around 1 nanometer. Diameter is 1 nanometer, and nanoparticles are those which are having their um, size from 1 nanometer to 10 nanometer. Those are known as nanoparticles. And since these nanoparticles are quite small, they basically, these nanoparticles have high amount of physical properties. For example, if you talk about their melting point, they have high amount of melting point around 2800 centigrade, alongside which, if we talk about their physical properties, then they are good conductors of electricity, excellent conductors of electricity, excellent conductors of heat. They are lightweight and have high surface area. How is this possible? What does the sense does it make? So when we talk about Bucky ball has basically got a hollow cage such that the entire from the interior the Bucky ball is empty. From the interior the Bucky ball is empty, and from the exterior it's just covered with a cage of carbon atoms linked together, due to which we call this structure as to be occupying a lot amount of high surface area. A lot amount of surface area is occupied by buckyball. As a result of high amount of surface area which is occupied by the buckyball, it causes the density of the buckyball to decrease because volume is quite high, due to which the Bucky Ball are light in weight. Now when it comes to the structure, that what is the structure formed of? So uh, it is basically a nanoparticle. One more thing that I wanted to just share over here is that buckyball are polyaromatic hydrocarbons. These are polyaromatic hydrocarbons. Aromatic hydrocarbons are those in which there is benzene ring, in which there is at least one benzene ring, which is basically a ring having alternate single and double bonds, and having at least six carbon atoms in it. And that's aromatic hydrocarbon. These are known as polyaromatic hydrocarbons because they have got multiple aromatic rings. There are multiple aromatic hydrocarbon rings. Let me just prove that as well. If you talk about the structure is basically made up of two major types of uh, units. Which number one is hexagonal unit, in which there are six carbon, and number two is pentagonal unit, which in which there is five carbon. Pentagonal unit, in which there is five carbon. When it comes to the hexagonal unit is basically are found 20 in number in each buckyball, and pentagonal units are found in 12 number in each buckyball, and all both each pentagon is linked with each hexagon. Hexagon and pentagon share their sides, and these are linked with each other. As you may see in this diagram as well, this structure from here to here, this is basically a hexagon, and with that hexagon we have linked a pentagon. So pentagon is linked with hexagon and vice versa within this, such that each hexagon is followed by a pentagon and vice versa. So in that sense, this is basically a basic uh, this is a basic of a buckyball. That's all about this video. Hopefully we'll make another video.